let us name this particular organic compound together. So, I always tell you guys that if you want to name an organic compound, what is the first thing to do? The first thing to do is to know the functional group. And what is the functional group of this compound? You can see COOH. COOH. So that tells us that what? That tells us that this is an alkanoic acid. So after knowing that, what is the next thing you should do? The next thing to do after knowing the functional group is to what? Is to identify what we call the LCCC, the longest continuous carbon chain. You need to count the longest continuous carbon chain, the C2C bonds, carbon bonding to carbon and carbon bonding to carbon. The longest one, that's the one we are going to select, and that's going to be our parent chain, right? That's going to be our parent chain. So if you count like this, if you count straight, 1, 2, 3, 4, 5, right? That's 5. You can count 1, 2, 3, 4, 5. You can count 1, 2, 3, 4, 5. You can count 1, 2, 3, 4, 5. You can count 1, 2, 3, starting from here, 1, 2, 3, 4, 5, 6, 7. So out of all of these countings, you can see that 7 is the longest. 1, 2, 3, 4, 5, 6, 7. That is, we are coming from this COOH till we get to C3H7, which is our propyl, right? So this is our longest continuous carbon chain. This is our longest continuous carbon chain, right? So now, ensure that your longest continuous carbon chain must include the functional group, right? Anytime you are counting your longest continuous carbon chain and it does not include the functional group, that means you are doing nonsense. Your longest continuous carbon chain must include the carbon bearing the functional group. This is the functional group. So your longest continuous carbon chain must include the functional group. So that means that if there were another functional group, or if there were a longest continuous carbon chain that is longer than this particular 7 that we counted, right? It's longer than 7, but the main functional group in the compound is this alkanoic acid functional group, then you will have to choose the longest continuous carbon chain that has the functional group. I hope you are following me, right? So after knowing that, you need to know your direction of naming. Are you naming towards the right or you are naming towards the left? For alkanoic acid, this is not like the alkanes that you have to be doing 1, 2, 3. You have to be using the position numbers of the substituents to determine your direction of naming. It is not like that in alkanoic acid. In alkanoic acid, it is the position of the functional group that determines your direction of naming, right? So now you can see you are going to name in a direction that is closer to the functional group, right? And in this particular question, the functional group is here. So your naming must start from here. Your naming must start from the right hand side. So this is going to be your carbon 1. This is going to be your carbon 2. This is going to be your carbon 3. This is going to be your carbon 4. This is going to be your carbon 5, 6, and 7, right? I believe you get me. So this is how it's going to go. 1, 2, 3, 4, 5, 6, 7, right? So now, after doing that, you need to identify your substituents, right? And you all know that substituents are attachments to the longest continuous carbon chain that are not hydrogen. This is our longest continuous carbon chain. 1, 2, 3, 4, 5, 6, 7, right? So what are things that are attached to the longest continuous carbon chain? We have bromine. So let me just write bromine. How many bromine? Okay, 1, 2. We have 2 bromine atoms. Bromine times 2. We also have chlorine. How many chlorine atoms? Just 1. So chlorine. After that, what else do we have? Okay, we have fluorine also, and we also have methyl, right? So fluorine, that is F. Just 1 fluorine. Also, we have methyl, right? We have methyl. How many methyl do we have attached? This one, this is a substituent. This methyl, and this methyl is also a substituent. Why? Because they are not part of the longest continuous carbon chain. Know that the longest continuous carbon chain is here. 1, 2, 3, 4, 5, 6, 7, right? So this methyl and this methyl, they are not part of the longest continuous carbon chain. So methyl also, if you check this thing very well, you can see that I'm highlighting this substituent alphabetically. That is something you must always do. Please ensure that your substituents are arranged in alphabetical order, right? So now let us start naming. So now our first bromine is on what? Carbon 3. Our second, both of them are on carbon 3. So you can just write 3, 3 dibromo. You need to put di to show that it is 2 bromine atoms, right? 3, 3 dibromo. Then you move to chlorine. How many chlorine atoms? Just 1. And it is on carbon what? 1, 2. It is on carbon 2. So you write 2 chloro. 2 chloro. Then you move to fluorine, right? Fluorine is on carbon what? Also on carbon 2. Then you write 2 fluoro. 2-fluoro, then we move to methyl. Our methyl is on carbon what? Okay, both of them, they are on carbon 4. This one is on carbon 4. This one is also on carbon 4, attached to carbon 4, right? So 1, 2, 3, 4. So we have something like 4,4 dimethyl, 4,4 dimethyl. Then what's the next thing? The next thing is to what? Put the parent name, right? Remember, what is the longest continuous carbon chain? The longest continuous carbon chain is what? 7, and that is what? Heptane, like as in heptane. That's where you have something like heptanoic acid. So the parent name is going to be heptanoic acid. So the name is going to be 3,3-dibromo 2-chloro 2-fluoro 4,4-dimethyl heptanoic acid. I believe this is very simple to understand. So let me give you something that you guys will help me name, and you drop the name in the comment section. So do this particular IUPAC naming. What is the name of this particular compound? And write your answers in the comment section.